Hi and welcome to our today demo, which is about ONAP and PANDA introduction. As we learned during the course, ONAP is a big software, is an orchestration platform mainly designed for service providers, which includes those different frameworks like the design framework, runtime framework, and also the closed loop frameworks. And PANDA, which is covered in the further sections of this course, is a big data analysis platform mainly designed for networking. In the new releases of the ONAP, it includes also the PANDA. So PANDA is becoming a part of the ONAP. So ONAP as a big orchestration platform also includes PANDA as a tool, as a platform for big data analysis of the networking. However, Panda can be also deployed as a standalone platform for doing the big data analysis. So it doesn't really need to be deployed along with ONAP, but deploying it with ONAP, it provides further integration with ONAP and data which is being created and generated by ONAP, and it can be fed into the Panda automatically. But with Panda, whenever you install the Panda standalone, or even if you have it with ONAP, still you will be able to feed some more data inside the Panda and doing some analysis work on those data which you are feeding into. One thing that we should remember is that ONAP and Panda, they are very big softwares. They consist of many different components, and they have a very complex installation methods. For proper operation, they require huge amount of resources of compute power, memory, and storage, and also requires a virtualization platform to run these two softwares. So normally we can deploy ONAP or Panda on OpenStack or Kubernetes, and also they have some complex way of the installation on the bare metal hardware. But the way that ONAP is currently recommending is to build a Kubernetes environment on top of OpenStack and use that environment for installation of the ONAP. And as I said, in the newer versions of the ONAP, there is an option to have the Panda also get installed along with ONAP, and it also does uh, the the required integration between the ONAP and Panda during the installation. So since these two pieces of software, they are really huge, we will be just reviewing the installation methods, and we will get familiar with the installers of the ONAP. We will look at the installer options, and we will do also some demonstration of the installation. But as I said, since it requires huge amount of resources, unfortunately, it becomes very complex to cover this in this introduction course. To make a fully working ONAP or Panda deployment and demo, it requires few hours of implementation and installation and integration, which is a complex process, and we will not be able to cover that into this introduction course. So for our demo today, we are going to use our Kubernetes environment, which we set up previously. We have the Kubernetes on-prem Kubernetes environment. We have the Juju console, we have a mass server, and we have a Juju controller, which we will not be doing actually any work with these. And we will go and get familiar with ONAP installation methods. We will review the different installation ways. We will also look at the Panda installation method as well. And we will start downloading and getting familiar with the ONAP installer. We will find out how we can change the installer options, what are the options, and how we can enable the installation of the Panda along with ONAP. And we will do also a demonstration of the installation of ONAP along with Panda over the Kubernetes, but we will not be able to complete this installation due to the lack of the resources which we have. All right, so let's have a look now on the ONAP website, and we start from there. All right, so let's start. We will go to onap.org, which is the website of the ONAP. And now from here, so here actually we have the Casablanca release, and we will jump directly to the get the code. And this leads us to this read the doc website of ONAP. And so this information, the release information of the Casablanca, it will show. And let's start with the installation. So installation, ONAP includes a piece of software which is called ONAP Operation Manager, OOM, which can be used for deploying ONAP over on top of the Kubernetes. We will be using this OOM, which is a pretty simple installation. Now, if we use the OOM information, so using OOM requires Kubernetes, Helm, kubectl, and Docker, and that's all is required. For a very basic installation, I think it has been validated with this 14 virtual machine and 16 GB of memory, but I think this is not very practical if you are planning to do a real test with the ONAP. This might be good for testing the installers that if they are working fine, but if you want to do any real test of the getting touch with ONAP, this is very small deployment. The installation also is supported using other methods, like you can use heat, OpenStack heat. So if you have OpenStack setup, you can use the OpenStack heat for deployment of the ONAP. But you need to have your OpenStack already set up, and with the basic OpenStack components, and also you need the heat as a separate component on your OpenStack. And using this, there is a heat file which you can download, and you can use this heat template file for deployment of the ONAP on top of the OpenStack. Also, there are other methods like setting up each individual components of ONAP, which also it becomes a very complex way because it has many different components, and you need to set up each of them manually separately and do the integration between each component and the other components as well. And the installation methods which are listed here, it also includes a creation of the Kubernetes, which is explained in this guide here. The OM Cloud Setup Guide, which here it specifies that to set up the ONAP, actually you need 224 gigabytes of RAM, and you need 112 CPU cores and 106 gigabytes of hard drive. And this tutorial here, it explains how to do the installation of the Rancher on top of the OpenStack in order to use this platform to create a Kubernetes and deploy ONAP on top of the Kubernetes. So this one here actually is a good guide which helps you to launch Rancher on top of the OpenStack. But as a prerequisite, you need the OpenStack running on your system, fully set up with different flavors set up, the storage and everything. And with this guide, you will be able to start creating your Rancher environment. So Rancher is another free software which can help you to run and create clusters of the Kubernetes or other big software tools. So here it is creating the Rancher virtual machine on top of the OpenStack with some configuration here. And once the Rancher is deployed, after that it will be doing some installation of the Kubernetes. And let's have a look more. Creating key pairs and stuff, and also we need to set up an FS share between the nodes of the Kubernetes. So the master node inside the Kubernetes will be serving an NFS share between all of the other machines. So this is one of the ways that they are going to share the data between each other. So there are some piece of code that helps you for creating NFS share on the master and also on the slave nodes, the other Kubernetes worker nodes in the cluster, to start pointing and using this NFS share which has been created inside the Kubernetes master. And once you set up the Rancher, as you see, some screenshots are here, you will be using the Rancher to create your Kubernetes environment. So you will have OpenStack, you create a Rancher on top of the OpenStack, and you will use that Rancher to create a Kubernetes environment on top of your OpenStack environment. One of the benefits of running Kubernetes on top of the OpenStack is that I think Kubernetes also integrates with OpenStack. So some of the those features which are not really available with normally with the on-prem environments of the Kubernetes, uh, like load balancers and allocating those service IPs of the load balancer, so that might be able to cover using OpenStack. And Rancher will do your setup of the Kubernetes on top of the OpenStack, and you will be once the Kubernetes is up and running, then you will be able to start doing the deployment of the ONAP on top of it. So this guide here was just a guide for helping you to create a Kubernetes environment on top of the OpenStack. So once you are ready and you have your Kubernetes environment ready to go, then you need to start with the OM Quick Start Guide, this guide, which can help you to start creating and deploying the ONAP on top of the Kubernetes. So we will be using also this guide because we already have a Kubernetes environment. Our Kubernetes environment is not running on top of the OpenStack, but it's just a standalone environment. It's not fully compatible with this implementation method, but we will be using it just for demonstration of the installation. So once again, this whole guide will tell us how to create a Kubernetes environment on top of the OpenStack, and also how to install the ONAP using the OM on top of that OpenStack, on top of that Kubernetes environment which we have already created. And as we discovered, there are other ways for deploying of the ONAP, for example, using Heat, OpenStack Heat, which ONAP comes with a Heat template, which can help us to create and spin up the ONAP on top of the OpenStack directly. And also there are other ways for setting up each individual component. And once we do this deployment, you will see that after the deployment, there will be around over 200 and something Docker containers will be, and Kubernetes pod will be spin up, and you will see how these components, they are all forming this whole ONAP all together. Also, these other documentations are very useful if you are interested to read more about the ONAP, for example, the service design. These are all hooking into into the confluence of the ONAP. For example, here you can see how you can get access to the ONAP portal. So ONAP portal is one of the services or containers within the ONAP, which is only serving a dedicated user interface for the user to interact with the ONAP. And from here you will be able to access to, for example, to the design framework. In the design framework, you will be able to find out how to create tenants, or how the region works. All of this stuff which we discovered and reviewed during the course are also available here in some places of the documentation. Within the Confluence, you will be able to find some interesting implementation guides and also information which might be very helpful. For example, here we got some running the ONAP demos. It will help you to understand how to access the portal, for example, and this kind of stuff. Also, there are some the overall deployment architecture. This also shows how actually the ONAP works. So it might be a little bit scary when you look at the drawings of how the different components of the ONAP are all working together, and all the different components of the ONAP. But remember, ONAP is a massive platform for orchestration. So it has so many connectors and drivers to talk to different components like networking and virtualization. And in order to create your universal CPU or edge computing or service chaining in the edge or within the core of the service providers, that's why all of these components are all required and they all talk to each other. So in different deployment, you don't need to deploy all of these components and features. You can enable and disable each of these. You might not need to have some of the features enabled. So based on the requirement, you can enable or disable the features and components of the ONAP. We will be look at these when we download and start doing deployment of the ONAP. Also, this conference gives us some more information about the other projects within the ONAP. So for example, if we go on the ONAP project, in the approved project, let's say the data collection analytics and event project. So here in the DCAE documentation, here we go, there is a section for integrating the PANDA. To provide the PANDA platform as a deployment option that delivers big data analytics as part of the DCAE. So the PANDA is being brought inside the ONAP for data analytics, for big data analytics. And this all information shows that how the PANDA is being brought in and how it works. So here also there is a presentation. And this presentation also should be able to give us some more information about the PANDA. So PANDA integrates and be offered as ONAP DCAE. One of the options for DCAE. It's still ONAP comes with its own big data platform. So the PANDA has option for big data processing for ONAP within the DCAE Gen 2 framework, providing an alternative to CDAP, which is the other data analytics platform of the ONAP. So PANDA is a real big data platform which comes with the Hadoop as well as opposed to integrated developer focused like the Red Panda. So PANDA is already coming into the ONAP. So if you are setting up the ONAP, we should be able to get the PANDA also integrated into that, and we should be able to use that. All right. So let's have a look at the PANDA also now. So if you go to panda.io, this is the general website of the PANDA. So PANDA also is a new project, so you will not be able to find some information which you may be looking for. And from here, we can just jump into the guide, and there are some implementation method also for PANDA. And so these implementation methods which are listed here, these are all out of the ONAP. So you can do the PANDA deployment using OpenStack Heat, or you can deploy it on the AWS, or we can deploy it also using the SaltStack automation tool. So let's say, for example, on AWS, here also it gives us some information how to deploy the PANDA on the AWS. So there are multiple different steps which needs to be done, creating the mirror components and all the stuff which are listed here. Using OpenStack Heat, there is a Heat template from PANDA which you can use that on top of the OpenStack Heat to create PANDA on top of that. And there are some guides also here for creating the image files and doing the implementation on top of the Heat. So either you can do deployment of PANDA using OpenStack or AWS, or we can just use the ONAP for deployment of the PANDA, which I think is easier to use ONAP for doing that deployment. Also, to remind you, PANDA, if you haven't read about the PANDA, that's already covered in the data analytics section of this course. And PANDA is a big data analytics for networking. So it includes a full-fledged big data components like Apache, Kafka, Hadoop, and you can create big data applications and tools on top of it for doing the big data analysis on top of your big data, on top of the networking information which is coming from your, for example, the BGP information or routing information, or even the movement of the MAC addresses, or anything which you can, or any other information which you feel that might be helpful for creating for doing some big data analysis on top of it. All right, so let's start with With ONAP installation, we will use the OM quick start guide, which we reached here, and we already have the Kubernetes environments available to us, and we will be using this guide for deployment of that. So let's have a look at our Kubernetes environment first. Let me get a console here. If I do a kubectl cluster info, this should show us some information about our Kubernetes cluster, which is running. So master, hipster, all the services are Kubernetes running. And also I have the proxy also running on a separate console. So we can use our browser to access to our Kubernetes environment. So I'm using this localhost at port, and I'm able to access to our Kubernetes environment, which is running on top of these a master server and two workers. So we don't have any specific configuration. This is just a bare installation of the Kubernetes. So that's what we currently have. So our Kubernetes is ready, and let's start from here. So for doing deployment of the ONAP, our Kubernetes environment is available, and the first thing is to clone the OM repository from the ONAP grid. So let's do this work. So let's start with doing this git clone, and it will create a folder for us called OM. Here I put this command, and we clone the OM repository. Let it get downloaded. Wait for it. Okay, so the repository has been cloned. Just remember, this repository is only the ONAP installers. So the Helm installer is not even the real files of the ONAP. And if we go to this folder now, the OM, and we got now the Kubernetes, Tuscas, and different folders, and we should go to the Kubernetes folder, which includes all of these other components of the ONAP. So cd OM or Kubernetes. Now we are over there. Now we need to install the Helm plugins required to deploy the ONAP Casablanca release. First, I need to make sure we have Helm installed on our machine. Let me check. Yeah, we have the Helm. So Helm is like a package manager for Kubernetes. So same way that, for example, you use Docker to pull images and install some software on top of the Docker containers. On the Kubernetes cluster, we can use Helm, which is a package manager for the Kubernetes, to install different charts inside the Kubernetes. So right now we have our Helm installed on this machine, and we will be using this Helm, which we are running actually version 2.2.13. So I need to, let me use my file manager here, and we need to copy the files from Kubernetes Helm plugins into a folder inside the local user.helm. So here should go to Kubernetes Helm plugins. So we got the Helm folder and the plugins, which includes two plugins called deploy and undeploy, and these two will become two different commands for us to be used within the Helm. And these two, they should be copied inside the local user. So I should have a folder here called .helm, and I need to copy these into that folder. So if I issue this command, here on the user directory, now I have a Helm, and I have these plugins already copied. So that is already there. It's already copied. Okay. Now we need to customize the ONAP values.yaml file to suit the deployment. You may want to selectively enable or disable the ONAP components. So this is one of the configuration files, the values.yaml. So if we go back here, let me open this file actually inside in a proper file manager, in a proper text editor. That will be easier. So in the OM, inside the Kubernetes, we have inside the ONAP folder the values.yaml. So inside this file, there are different components which are enabled or disabled. So these are all the ONAP components which we have already studied. And for example, each of them have different configurations. So for example, APPC, which is the application controller. For example, the APPC or the application controller, it requires OpenStack environment to be available to spin up. So APPC requires OpenStack, and here we have to provide the OpenStack information here, the tenant name, the username, password, and stuff in order to APPC to be able to spin up itself on top of the OpenStack. The other stuff, like as you can see, the clamp, Panda is also here, and it's enabled, it says false. Now we will change this to true. So this will tell to our OM installer that, hey, I need Panda to be installed as part of our ONAP deployment. And the other components, as we can see, they're all there. The policy, reboot, service orchestrator. So service orchestrator, as we studied, it's a runtime component of the ONAP, and this also requires the OpenStack, so it runs on top of the OpenStack. So you need to modify this information based on the OpenStack platform which you have. Unfortunately, here we don't have that OpenStack environment, and we are just running bare metal Kubernetes. We will not be able to have the service orchestrator enabled. So this actually will fail during our installation. I will not change it to false, but I want to make sure that's already there. And the other components are also all enabled, so that's what we needed. So these are the values of the ONAP. Let me save this file, and now if you go to the other folders, like let's say the portal, for example. So portal, also each component has its own values of the YAML file. So these are the configuration, for example, for the portal. So that's one of the components of the portal port, what port the portal should be listening on, the passwords and stuff, they are all listed here. What database in the MariaDB, it has to work, it will be so our installer will create a MariaDB or MySQL database file called portal-db, and this is how the portal will know that how to use that. And these are all preset passwords which are defined here for doing this connection between these different components. Other components also as well, you will find all of this stuff having a separate value.yaml file. So for example, this one, the Panda also has different requirements. So the Panda DCAE, Panda Bootstrap, this also has its own value configuration file which requires to be modified. So the Panda, when it comes up, it requires 1 Apache Kafka nodes, 2 data nodes, what NTP server is going to use, and other stuff. So each of these values.yaml file needs to be modified based on what you require. And requirements.yaml, this is a Helm file that specifies what are the requirements for this package to be. All right, so let's start with creating our Helm server here on this machine. So Helm server here will be helping us to create a local repository, Helm repository for our deployment. And we will be creating a local repository after that, and we will create this ONAP installer chart installers within this machine, and will be served via this Helm server to the Kubernetes environment. So let's start the Helm server now. Okay, so let's start the Helm server. Helm serve amp, and all right, now it started on the local machine port number 8879, and we still can use the console. Let me check if it is really running here. And yes, the Helm is running here. Okay, so we got our Helm server running. Now just remember, we have the Helm server and Helm client running on the same machine. If you remember, when I do the Helm version, we have the both Helm server and client running on the same machine. So we have the Helm server running on version 2.13, and now we need to add the repository. So Helm add this local repository. So this is a command for the Helm client. Okay, I have to run it with sudo. Okay, it's added to repository. If I say Helm repository list, and we can see we have the local repository also added here to our Helm client. Okay, so this we have already done. Now we are ready for compiling the our Helm repository, for creating the ONAP installation repository. Now before doing that, we need to the version of our Helm, we need to ensure that is correctly specified inside our ONAP installations. So the version which we are running here is 2.13.1. Now this version should match with the version which is specified in our ONAP installation. So in the Kubernetes folder, ONAP, in the charts.yaml file, so here we have a Tiller version, which is actually the version of our Helm client and Helm server. So it should be 2.13.1, matching with the version which we have here. Otherwise, we will get some errors during the deployment. So let me save this file, and we should be ready to go with running the make all and make ONAP. I will run it separately here. Let's do it with sudo make all. So this process will take some time. We will wait for some time for it to get over. It may take around between around 30 minutes to an hour for it to get over. So let's wait for it to get over. All right, so now as we can see, the compiling is completed now. No failures. Okay. So this whole thing actually just created the package ONAP 3.0.tgz. Let's see how big is this file. The ONAP. It's just 1 megabyte file. Okay, so the next is to do the make ONAP. Let's give it some time, let it get over. All right, so now this make also is completed, no failures. Now if we do a Helm search -l, this should show us all the repositories inside our Helm. These are all the repositories, so include also WordPress. Let's see. Let's do a filter of ONAP. And yeah, so local in the local repository ONAP version 3 Casablanca is already there. Open Network Automation Platform. So this is already created as we expected, and now we are ready for the repo setup. The installation of the ONAP can be done with this single command. So helm deploy dev local slash onap dash dash namespace onap. So this will create a namespace called onap within our Kubernetes, and we'll start deploying this whole big piece of software, the ONAP, with all of its components, including Panda, inside our Kubernetes environment. Let's check in our Kubernetes. Let's make sure we don't have the ONAP namespace. If I click on namespace, let me log in again. Okay. So namespaces, so we have just the default namespaces of the Kubernetes. We don't have any ONAP. So now we are ready to go with the deployment. Helm deploy as a command, and let's do it also with sudo. There we go. So this will take some time for deploying the whole thing inside the Kubernetes. So it grabs all the requirements and charts from the repository which we have created, and it start talking to the Kubernetes to create different create the deployment, creating pods, services, persistent storage, and all the other stuff. Let's give it some time now. All right, so now as we can see, most of the component has been deployed. We got few failures here, which are didn't get deployed. Now let's have a look at our Kubernetes and see how these items are being deployed. Okay, let's go back to our Kubernetes. Now here, if we go on, okay, so we are in the overview. Let's see if we got new, yeah, we got new namespace. We got the ONAP namespace, and within the ONAP namespace, now as you can see, the memory utilization is just going up because the hosts are being created, the containers are being created, and the deployment has already started, and the number of deployments, 120 deployments, around 17 jobs, and the pods also being created, 159 as of now, and replica sets. So this is how ONAP is being deployed. We just need to give some time, but after all, within this environment it will not be really useful, because this demo was to show you how you can do the installation, but if you can use a native cloud Kubernetes, like Kubernetes on Azure or AWS or Google, that will be a straight deployment without any problem. Because we have in the lab, we have only this Kubernetes on the bare metal, so it doesn't support all the features. So after some time, we will see that the memory utilization will go above the 100 gigabytes. Most of the containers will be created here, but it will not be fully operational. Yeah, and just refresh the page, the Kubernetes overview, and as we can see, our memory usage on our host has reached to around 189 gigabytes. So this means that most of the containers of the ONAP has been deployed and they are running. So this demo was all about very basic introduction for installation of the ONAP, and enabling Panda also for the installation along with the ONAP. But as I said earlier, the ONAP and Panda, they are very complex platforms for automation and data analytics. We will not be able to cover the full-fledged demo of ONAP or Panda within the scope of this course. But these are complex softwares. Even if you compare ONAP or Panda, both you can compare them to OpenStack or Kubernetes. These are all complex softwares and require a very advanced type of installers for having a clear installation. Once we have the Panda installed, we just need to start writing application and ingesting logs to the Panda in order to start getting knowledge out of our data. So this was our very basic demo about ONAP and PANDA. If you have any question, please raise it in the forum or you can contact me directly. Thank you very much.